Assalamualaikum dan salam sejahtera. So in this session, we will discuss 5.3, that is linearity test. So what is linearity test? Okay, as usual, we know that the core business of statistics is to do hypothesis testing. Okay, so linearity test refers to whenever we have a linear model, for example, y hat equal to beta naught, beta 1, and x. So we want to test whether this value, especially the slope, the slope, which is the regression coefficient, that we have is significant or not. So that is what we want to test. Okay, so if beta 1 is significant, okay, then there is linear relationship between the independent or between x and y variables. Okay, so that is what we want to test. Okay, so we are going to use two methods. One is using the t-test or test statistic of t. Okay, another one is using ANOVA, or analysis of variance that you have learned in chapter 4. Okay, ANOVA is in chapter 4, so where it used this table here. Okay, you have sum squares, sum squares, and then you have degree of freedom, mean square, and F critical, F test. Okay, so so this kind of table, ANOVA table. So you need to construct this. Okay, and of course this one using Excel, from Excel. Okay, next. Okay, for the first method that is using t-test, so two variables have a significant linear relationship if the slope of regression line is not 0. And I mentioned just now, if beta 1 is significant, that means beta 1 not equal to 0, then there is a linear relationship between the variables. So the hypothesis testing of regression slope is also known as linearity hypothesis test. Okay, so it is a two-tailed test. Why? Because when we state the H0 and H1, H0 will be beta 1 equal to 0, and H1 will be beta 1 not equal to 0. So it becomes two-tailed test, two-tailed test. Okay, so that means when you draw the t distribution, if you visualize it, you have this one, left and right. So you have minus t alpha over 2 degrees of freedom, and this side t alpha over 2 degrees of freedom. Okay. For the hypothesis, you either use symbol, mathematical symbol to express the hypothesis, or you can write in words. The slope of regression line is 0, and the slope of regression line is not 0. It means the same thing. Okay, so this is the formula for the test statistic. Okay, so t test should be t test equal to beta 1, beta 1 my beta 1 hat, this one from the sample that we have, from sample. Okay, so beta 1 without the hat, this is the what we call hypothesized value. Normally it is not given, so we assume 0. And then we have this one is standard error. SE beta of beta 1 is standard error, where it is calculated using this formula, standard error, which is SYY minus, okay, this is the formula for standard error, the square root of mean residual times 1 over SXX. Okay, so the mean residual formula, this part, this is mean residual, and this is 1 over SXX. So we have learned how to determine SYY and SXY, okay, and for in the denominator n minus 2, So n pairs, n is the number of pairs, yeah, not the number of total in a sample, yeah. So n is the number of pairs, yeah, because when we do regression, we look at pairs of x and y, yeah. So it is two-tailed, so that is why you have left and right, yeah, left and right. Okay, so this is minus t alpha over 2. Okay, of course you have 0 in the middle. Yeah, and so on. So this is the test statistic. Okay, and then for the critical value, okay, so you are going to test where is your critical value located. Yeah, so you are going to compare t test, yeah, versus T critical, which is T alpha nu over 2. Okay, so in this case, we use the two-tailed test. Okay, so if yeah, so let's say this is our critical value, yeah, T alpha over 2 degrees of freedom, and this is negative T alpha over 2 degrees of freedom. So if our T test is here, fall here, yeah, or here, yeah, T test, that means we do not reject H naught. Yeah, otherwise in the shaded area, if it is here, yeah, or here, we reject H node. Yeah, H node. If t test is here, so it depends on your sample. Yeah. Okay. The second method that we can use for the decision rule is using p-value method. Yeah, that I mentioned in the last session. Okay, p-value is simply probability value. So to use p-value method, we compare with alpha. Yeah, so do not confuse with using critical value method and using p-value method. Yeah, so p-value method, you need to calculate compare the p-value versus alpha, the critical, the significance level. Okay, so p-value, if it is less than alpha, then we reject H naught. Yeah, otherwise we do not reject. Okay. Okay, conclusion, at alpha, the slope of regression line is not 0. If it's not 0, that means beta 1 is not equal to 0. That means there exists linear relationship. Yeah, so that means beta 1 is significant. Yeah, significant, that means not 0. Okay, so there exists linear relationship between independent, which is x, and y dependent variables. Okay. Okay, you can go through this example, okay, using the data result, the same example from 5.2 and 5.4. We can use the linearity test to check whether the coefficient is significant or not. Okay. So from the example, okay, we have this equation. We have the predicted linear equation, yeah, simple linear equation. So this is the predicted that we have, okay, where this is beta naught, yeah, beta naught hat, and this one beta 1 hat, okay. So we want to check whether beta 1 is really significant or not. And we have this summation already that we have calculated before, okay. Next. And then we use this test statistic formula, yeah, t-test, yeah. So substitute the value that we have, beta 1 hat minus beta 1, yeah, in this case, beta 1 equal to 0. Yeah, standard error, yeah, simply use this formula. Okay. Okay, right, should be that, yeah, okay. So you will get this value, and then, yeah, okay, then you will calculate, the t-test is 7.0637. Okay, and then you are going to compare. So in this case, alpha is not given, so you take alpha 0.05. Okay, so the critical value will be divide by 2, so 0.05 divided by 2, 0.025, 6, yeah, 6 because you minus 2, yeah, so degrees of freedom is 8 minus 2, 8 pairs minus 2. Okay, so this is, if you look up in the tables, you got plus minus, so in this case you have this one. Okay, you have the critical value. This one negative T 0.025, yeah, 6. So which is negative 2.4469. Okay, whereas this one will be T 0.0256, yeah, which is equal to 2.4469. Yeah, so then we are going to locate our t-test. Yeah, so you see that our t-test is in the shaded region. Yeah, in the shaded region. Therefore, we are going to reject the null hypothesis. Yeah, H note. Yeah, so but you need to write it properly. That means you can write t-test value is greater than t alpha or t 0.0256, yeah, then reject H note. Yeah, so you must state this. Yeah, you must state this and also your decision here. Okay, and then finally you can conclude. Okay, so similarly, okay, finally you can conclude that at 5% significance level, we can conclude that the slope of regression line is not zero. Yeah. Hence, there is sufficient evidence that the student's final mark is related linearly to the number of hours students spend to study. Yeah. So there is a linear relationship between final marks and also the number of hours students spend to study. Okay. So in the next session, we'll do one exercise. Okay.